After months of speculation, satellite images, leaked internal memos, and a series of unusually timed supplier movements, the first dedicated production line for the Tesla Model 2 Senior Edition 2026 is finally up and running. The biggest bombshell isn't that Tesla built it, it's how fast they built it and what this new line is designed to produce. But here's the question everyone over 50 has been quietly asking. Is this new Senior Edition truly engineered for older drivers? And with Tesla accelerating output at an unexpectedly aggressive pace, how soon will we actually see the first units roll off this line and onto real American roads? That's exactly what we're breaking down in today's report. Before we dive in, a warm hello from us here at AutoGearshift. If you want to help us push this channel past 16,789 subscribers, hit that subscribe button and ring the notification bell. Think of it as your way of telling the algorithm, give me the real Tesla news, not the fluff. How did Tesla stand up a Model 2 Senior Edition production line faster than any sub-$30,000 EV in history? Tesla's decision to stand up a dedicated production line for the Model 2 Senior Edition wasn't simply a manufacturing expansion. It was a complete rethinking of what a compact EV line should look like. And judging from satellite photos, supplier manifests, and internal timing estimates, Tesla appears to have constructed this line in a window that borders on unprecedented efficiency, around 82 days from initial equipment arrival to calibration mode. That's astonishing, not because it's fast, but because of the type of equipment installed and the sheer number of specialized subsystems stitched together in such a short period. Unlike legacy automakers, who generally retrofit slow-moving conveyor systems into existing plants, Tesla built a hybrid linear cellular line where gigacasting, battery pack assembly, and ergonomic interior modules feed into the central line through parallel microstations. You can literally see the philosophy: minimize part travel, shorten takt time, cut human movement, and reduce dependency on multi-step welding. The heart of this line is a pair of 6,500-ton rear and front gigacast presses supplied by Idra, which arrived in staggered shipments over a 15-day window. Each press sits on a reinforced concrete slab with vibration-dampening plates to stabilize the structural castings during rapid cycling. These presses don't just replace welding, they collapse nearly 270 individual stamped and welded pieces into two massive castings. Even more interesting, Tesla slightly redesigned the casting alloy composition to reduce brittleness and remove 1.3 kilograms of redundant ribbing, leading to smoother injection flow and fewer defect rates per cycle. From casting, the line flows into a short-travel robotic machining corridor, where 8 FANUC precision units trim, drill, and finalize mounting points. The corridor is only 31 meters long, significantly shorter than the 52-meter ID.3 machining corridor Volkswagen uses. That distance reduction alone eliminates roughly 14 seconds per unit, which across 100,000 units annually can save over 390 hours of cycle time. Battery pack integration is another major divergence from older Tesla lines. Instead of using a wide-format battery deck like the Model Y, the Senior Edition line uses a narrow pack module mating station. The battery is lifted into the structural shell using a synchronized triple arm lift, calibrated to a deviation threshold of just plus or minus 0.7 millimeters. This accuracy allows Tesla to bolt the battery pack directly into the casted frame without additional shimming, reducing assembly time by 5.2 minutes per vehicle. Interior assembly is where things get very Senior Edition. Tesla added a dedicated ergonomic cabin module cell, positioned only 18 meters from the main conveyor, where pre-assembled comfort components, low-effort door hinges, wider-angle seat rails, soft-load glove box, and reduced resistance steering linkage are built as a single cabin block. That block is then robot-indexed into the structural body in one movement, a technique borrowed from aerospace fuselage installation. This reduces labor input, minimizes panel misalignment, and ensures consistency for the demographic who value comfort above sporty rigidity. What ties the entire line together is Tesla's modular layout. Instead of one long, uninterrupted conveyor typical in Toyota or GM compact EV factories, Tesla built the Senior Edition line as a 5-module chain, each with its own micro-buffer and error isolation capability. If one module needs recalibration, say the casting press or the ergonomic module cell, the rest of the line can continue operating in partial throughput mode, reducing downtime dramatically. Early estimates suggest this design targets a sustained pace of 92,000 to 110,000 units per year, with a theoretical maximum near 128,000 units once second shift optimization kicks in. No competitor in the sub-$30,000 EV range, not even BYD's Dolphin Mini or GM's canceled Bolt replacement, has a line this integrated, this compact, or this optimized around aging drivers. What battery strategy is Tesla using for the Senior Edition? With the Senior Edition targeting practicality over raw performance, Tesla's battery choice becomes the defining factor for range, weight, cost, and long-term durability. What's emerging from supplier inventories and China to Fremont logistics data is that Tesla isn't locking the Senior Edition into a single chemistry. Instead, they appear to be prepping 3 parallel battery options for 2026: an upgraded LFP pack for base trims, a sodium-ion pack for high-durability markets, and a small pilot batch of aluminum-ion modules reserved for fleet testing and early adopters. Each chemistry brings a different benefit, and each fits an older demographic in a very specific way. The backbone of the launch model will still be LFP, supplied through Tesla's existing China-based partners, but reworked into a 42 to 46 kilowatt-hour narrow pack design. Range estimates land between 295 and 317 kilometers depending on wheel size, but the real improvement isn't range, it's stability. LFP can handle 6,000 plus full cycles before drifting downward, meaning a Senior Edition, driven 15,000 kilometers per year, could last well over 15 years before showing noticeable decline. For a demographic that values reliability over exotic chemistry, LFP remains the most grounded option. But the real surprise is the sodium-ion expansion. Tesla appears to be sourcing trial quantities of Neon cells rated around 135 watt-hours per kilogram, slightly lower than LFP's typical 155 to 165 watt-hours per kilogram, but with far better cold weather performance. Sodium-ion remains stable down to minus 20 degrees Celsius, which solves the winter range collapse that older drivers constantly complain about. A 2026 Senior Edition, equipped with a 38 to 40 kilowatt-hour Neon pack, could still deliver 240 to 255 kilometers, but with noticeable improvements in winter consistency. And more importantly, sodium packs are cheaper to produce, roughly 22 to 28% less raw material cost, because they avoid lithium and nickel entirely. For fixed-income buyers, that matters more than headline range. Then there's the wild card: aluminum-ion. While not ready for mass adoption, Tesla seems to be lining up a micro-run of 18 to 22 kilowatt-hours aluminum-ion range extender modules to pair with the LFP pack. Aluminum-ion cells can recharge in under 90 seconds in lab conditions, offer massive cycle life approaching 10,000 cycles, and deliver extremely stable voltage under load. The problem is energy density, currently hovering around 110 to 120 watt-hours per kilogram at best. So instead of relying on aluminum-ion as a standalone pack, Tesla's strategy looks like a hybrid, using a small aluminum-ion layer as a rapid recharge buffer to support short urban trips for older drivers. A driver could top up during a grocery stop and regain 40 to 50 kilometers almost instantly. What can Tesla's production signals tell us about the real 2026 timeline? By studying Tesla's historical rollout patterns, supply chain timing, pre-production tooling cadence, and early vendor activity, a clear window begins to form. First, the newly completed Senior Edition line entered calibration mode around late Q3 2025, based on equipment activation patterns and logistics timestamps. Historically, Tesla needs 11 to 14 months from line calibration to the first volume production customer deliveries. The Model Y in Berlin took 13 months. The Fremont Model 3 line took roughly 12.8 months. Even the Cybertruck, with a far more complex production system, followed a similar 12-month rule from press activation to first deliveries. If Tesla holds that pattern, the Senior Edition's earliest realistic road debut would fall between August and November 2026. Second, the casting line configuration gives another clue. Tesla installed 2 gigacast presses, but activated only one for initial calibration. The second press is in cold-ready mode, not yet running molten alloy but fully installed. For the Model Y, the gap between press calibration and regulatory road testing was about 19 weeks. If the Senior Edition follows the same curve, early test mules should appear around April to May 2026. These sightings usually start about 3 to 4 months before Tesla's public unveiling event. Third, battery supply alignment is key. The LFP pack is already in ramp readiness. Sodium-ion pack vendors have logged mid-2026 delivery windows, and aluminum-ion micromodules are in sample-only status. This triangulates toward a launch version equipped with LFP only, with sodium-ion likely joining in a late 2026 secondary trim. That strongly implies Tesla wants a soft launch with one chemistry first, not all three at once. Put all these signals together, and the most logical timeline emerges. The Model 2 Senior Edition is almost certainly headed for a formal unveiling in mid-2026, followed by first customer deliveries in Q4 2026. And that wraps up everything we know, and everything we can logically project, about the first dedicated production line for the Tesla Model 2 Senior Edition. Now it's your turn. Do you think Tesla can actually hit a late 2026 delivery window? Drop your thoughts below. Your comments help us fine-tune every report. If you enjoyed this breakdown, hit like, subscribe to AutoGearshift, and turn on the notification bell so you never miss the next deep dive into Tesla's most important upcoming models.